Hi there. So we will be seeing how push down automata works with the help of our model. So push down automata is a finite automata with extra memory called stack, which helps us recognize context-free languages. So the working structure for push down automata is as shown in the figure. We'll be providing a input tape to our machine. The input will be passed on to the control unit, which uses the help of a stack to decide whether to accept or reject our input tape based on a problem statement. So pushdown automata is a machine that can be defined using all the 7 symbols mentioned here. So Q is the set of states which is a finite set of states, like in our current example it's Q1, Q2, Q3 and Q4. So sigma is the set of input symbols which will be determining whether to accept or reject our input string. So in our context, in our current scenario, we have symbols as 0 and 1. So after this we got is the set of which can be pushed and popped from the stack delta. So this is nothing but again our zeros and ones, because only 0 hash and 1 can be pushed onto the stack. So these will form the set of push down symbols, and Q0 is the initial state. So in our context it's to be 1. Z is the initial push down symbol. Okay, so F is the final set. Find the set of final states. In our example there is only one final state, that is Q4. And transitions, like for example Q1 comma 0 gives us 0, Q3 comma 1 gives us lambda, and so on. So in our current example we will be learning how PDA works for the example 0 power 1, 1 power n when n is greater than or equal to 0, to accept strings that have equal numbers of zeros followed by equal number of ones. So in our example let us consider 00 and 11, and let us start a model and visualize how the process in pushdown automata works and whether the string has to be accepted or not. So starting with our first step, so we are gonna be in our Q1 state. So next step, as soon as we encounter a 0, we'll be moving on to the Q2, which will be pushed onto the stack, and again a 0, which will be pushed another 0 on the stack. For our current example, as soon as we encounter things other than 0, that is 1, we'll be eliminating, that is popping out the 0 which was initially pushed onto the stack. So let us go through. So we are done with two zeros, two input variables done. So now the next variable is gonna be 1. So using that 1 we are gonna pop the first 0 which was on the top of the stack, and again another 1 which will give us 0, Q3, and at the last step, as there are no variables left, it moves on to Q4, that is the final state, and we can see that our string is accepted, which because it has reached to the correct final state. Machine has reached to the correct final state. So we are gonna look in another example by taking 00 1 1 1. So let us start this. So initially we are gonna stay on Q1. As soon as we encounter 0, which will be pushed onto the stack, and another 0 which will be pushed onto the stack again. Now there are two zeros and three ones, so there is one extra one here, so which is not possible for a string to be accepted. So in this case our machine won't reach to a final state, which indicates that this is not a valid string and the machine has rejected the input string. So as soon as we encounter the first one, we are gonna pop first 0 out, again pop the second 0 out, and next we are left with one more 1 which cannot be, as there is no transition defined by 1 that moves on to the final state. We are going to stay on the same Q3. So next step is rejected, incorrect final state. So if at all we pass Equal number of zeros followed by equal number of ones is when our string gets accepted or else it gets rejected. Thank you.